welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics class 11th, and that is your class is your 26, where we had completed your 25 classes. This is your class unit that we have to discuss is unit 4, which is motion in a plane. This is the first class of unit 4. Unit 3 and Unit 2, Unit 1 of Part 1 of Physics we had done. Unit 1 is your physical world. Unit 2 is that what we had discussed, and Unit 3 as well we had discussed about it. So motion in a straight line. Now I discuss motion in a plane, and here you will discuss the motions which used in a plane, and in the x, y, z axis, along with the axis that we discussed here. Before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So let's start with. So for the same we go for it, and we'll discuss about the motion in a plane. So first, in motion in a plane, we'll discuss about the introduction, what actually motion in a plane is all about. So motion in a plane, here in the last chapter, which is motion in a straight line, here that we developed the concept of the positions, displacement, velocity, acceleration that are needed to describe the motion of an object along a straight line. And we found that the directional aspects of these quantities that can be taken care of by plus and negative sign as in one dimensions, and only in the directions are possible. But in order to describe the motion of an object in 2 dimensions, which is a plane, and a 3 dimension, which is a space, so we need to use vectors to describe the above mentioned physical quantities. Therefore, it is first necessary to learn the language of vector. What is vector? How how to add, subtract and multiply vectors, and what is the result of multiplying a vector by a real number here. So on the same way here, that is what is the result of multiplying a vector by a real number. We shall learn this to be enable us to use a vector for defining the velocity and acceleration in a plane. We then discuss the motion of an object in a plane as a simple case of motion in a plane, and we shall discuss the motion with constant acceleration and treat it in detail, the projectile motion, where the circular motion is a familiar class of motion that has the spatial significance in daily life situation. We shall discuss the uniform circular motion in some detail, the equation developed in the chapter for motion in a plane that can be easily extended to the case of 3 dimensions. So now we discuss about the scalars and vectors. So we go for it. Scalars and vectors. So what is a scalar and what is vector? That is, you have to answer it out. Here in physics, we can classify the quantities as scalars or vectors. Basically, the difference is that the direction is associated with the vector but not with the scalar. A scalar quantity is a quantity with magnitude only. It is specified complete by a single number along with the proper unit. Examples: the distance between the 2 points, mass of an object, the temperature of the body, and the time at which a certain event happened. Where the rules of the combining scalars are the rules of the ordinary algebra. A scalar can be added, subtracted, multiplied, and divided here, just as the ordinary numbers. For example, if the length and the breadth of a rectangle is 1 meter and 0.5 meter respectively. Then its parameter and the sum of the length of the four sides will be 1 meter plus 0.5 meter plus 1 meter and plus 0.5 meter, that is 3 meter. The length of each side is a scalar and parameter is also a scalar here. So I just write it on the scalar definitions first so that it will be helpful to you. So here we go. A scalar quantity is a quantity is a quantity with magnitude only. Examples. So first example, I just take it, the distance between 2 points. The another example, we take mass of an object. These were the examples here. So other than that, we'll discuss about further about scalar quantity here. So here we go for it. On the same way, here that you have to take another example, that the maximum and minimum we just had added up, and the length of each side is a scalar and a parameter is also a scalar. So you have to take another example, like we'll take that the maximum and the minimum temperatures of a particular day are 35.6 degree or 24.2 degrees Celsius respectively. Then the difference between the two temperatures is 11.4 degrees Celsius. Similarly, if a uniform solid cube of aluminum of side 10 cm has a mass of 2.7 kilogram, then its volume is 10 to the power minus 3 meter cube, which is a scalar, and its density is 2.7 into 10 to the power 3 kilogram meter inverse, which is also a scalar. Now we talk about the vector. So on the same way we talk about it here, and we go for it for the same as well. So in a vector quantity, that is a quantity that has both magnitude and a direction and obeys the triangle law of addition, or equivalently the parallelogram law of addition. So a vector is specified by giving the magnitude by a number and its direction. Some physical quantities that are represented by the vector are displacement, velocity, acceleration, and forces. So we go for it. For a vector quantity, is a quantity that has both a magnitude and a direction. And obeys the triangle law of addition, or equivalent the parallelogram Law of addition. So vector is specified by giving its magnitude by a number and its direction. Some physical quantities that are represented by the vector are displacement, velocity, acceleration, and force. To represent a vector, we use a boldface type in this book, and thus a velocity vector that can be represented by a symbol. And since bold faces and uh, some physical quantity that will be represented by a vector, so I just tell you example, which is your displacement, velocity, acceleration, force. Okay, on your same way here, that since the boldface of the difficult to produce, so when written by hand, a vector is often represented by an arrow placed over a letter, that is V, and that has been representing as V, with an arrow here. So thus both this inverted a triangle and a vector with arrow that represent the velocity vector, where the magnitude of a vector is often called as an absolute value, indicated by the absolute value that will be V. Thus a vector represented by a boldface, it will be the capital A, small a, b, q, r, that is all in the form of a bold, with respect to the magnitude that is denoted by the light face. And now I'll discuss about the position and displacement vector. Position and displacement vector here. To describe the positions of an object moving in a plane, we need to choose a convenient point, say O as origin, and let P and P dash will be the positions of an object at a time t and t dash respectively, and we join O and P by a straight line. Then OP is a position, that is vector of the object at time t, and an arrow marked with the head of the line, and it is represented by the symbol R. So point P, on the same way, it is represented by the another position vector, which is OP, and that is denoted by R dash, and that the length of the vector represent the magnitude of the vector, and its direction is the direction in which P lies as seen from O. If the object moves from P to P dash, the vector P and P dash with a tall at P and tip at P dash is called the displacement vector, corresponding to the motion from point P at the time t to point P dash at the time t dash. It will be represented as follows. This is position and displacement vector. Another we have This is displacement vector PQ and different courses of motion. It is important to note that the displacement vector is the straight line joining the initial and final positions and does not depend on the actual path undertaken by the object between the two positions. For example, that is given initial and the final positions as PU and Q. The displacement vector is the same PQ for different paths of journey, say PABCQ and PDQ and PBEFQ. Therefore, the magnitude of displacement is either less or equal to the path length of an object between the 2 points. So this fact was emphasized in the previous chapter and also while discussing the motions along a straight line. We discuss about the equality of vector. In terms of equality of vector here, the two vector A and B that are said to be equal if and only if they have the same magnitude and the same direction. So here that shows the two equal vectors A and B, and that we can easily check their equality, and since B parallel to itself and until at all Q coincides with A, so Q coincides with O, and then since their tips S and P also coincide with the two vectors and are that said to be equal. In general, equality isn't indicated as A equals to B, so we go for it. This is the one. There are the two equal vector A and B. This is A dash. This is B dash. This is Q dash. And there are the two vectors A dash and B dash that is unequal through they are on the same length here. Now for the same, it will be note that here the vector A and the A dash and the B dash have the same magnitude, but they are not equal because they are different directions from F. We shift B dash parallel to itself so that it falls its tail Q coincide with the tail O dash of A dash, and that the tip S dash and the B dash does not coincide with the tip B dash of A dash. Now we discuss about the multiplication of the vector by real number. So for the same, it will be that multiplying a vector A with a positive number lambda, that goes a vector whose magnitude is changed by the factor lambda, but the direction is the same as that of A. So here lambda A if lambda is greater than 0. So for the same, here that, for example, if a is multiplied by 2, the resultant vector 2a is in the same direction as a and has a magnitude twice as that we have absolute a, and the multiplying of vector a by a negative number and lambda, that gives a vector lambda a and whose direction is opposite to the directions of a and whose magnitude is approximately lambda times of a. So multiplying a given vector a by negative number, say -1 or and 1.5, -1.5, that gives the vector that to be shown here. So you just go for it. This is minus there, minus 1.5 here. So here the factor lambda by which a vector a is multiplied, that could be scalar and having its own physical dimensions. So then the dimensions of lambda a is a product of dimensions of lambda and a. For the example, if we multiply a constant velocity vector by duration of time, then we get the displacement vector here. Now we go for addition and subtraction or vector, which is a graphical method. Let's go for it. Addition and subtraction of vectors, it is graphical method. So here in the same as mentioned in this that we had discussed in the last one, and that by definition that obeys the triangle law of equivalent the vector, as I told you in this class only, that the parallelogram of law of addition also. We shall now describe these laws of additions using the graphical method, and let us consider the two vectors a and b that can be lie in a plane, and that the length of the line segment that represents three vectors that are proportional to the magnitude of the vector. To find the sum a plus b, we place the vector b so that it tails is at the end of the vector a, and as a figure will be drawing, then we join the tail of a to the hand of b, and this line OQ represents the vector r, and that is the sum of the vector a and b. And since is this procedure of vector addition, the vectors are here where the vectors are arranged head to tail, and this graphical method is called the head to tail method, and the two vectors and their resultant form three sides of triangle, so that the method is also known as triangle method of vector addition. And if we find the resulting b plus a as the same the vector r, then that defined obtained the vector addition in a commutative. So we'll go for the first diagram and then we'll go further here. So which is reading as follows. This is b, here it is a, so here this is the resultant, this is a, this is, so this is b as that has been mentioned here, this is an b and this is a, so which will give you as resultant OQ, which is or equals to a plus b, and for another case it will be this is B, this is A, and so this is R equals to B plus A. Another we talk about it for the another way. We'll discuss about it. That is the another way. So we go for it. A, this is B, and this is B plus C. C, B, and this is A. We are just merging it out. A plus B. This is B plus C, and this is A plus B plus C, and this is your A plus B plus C. Okay, so this is been representing here. So for the first one we go for it, that is the vector A plus B, and the second is a vector A plus B added graphically. The third one will be having is your vector B and B added, and the last is illustrating the associative law of the vector here. Now for the vector addition is commutative, so it will be in the form will be A plus B equals to B plus A. Okay, then we'll discuss the another one, which is being as follows, and that is your another way. There are additions of vector that also obeys the associative law here, and the same way when they are following the associative law as illustrated, and that the result of adding vector A and B, that first and then adding vector C in the same as the result of adding B and C first and then adding vector A. So it will be giving you for associative A plus B plus C equals to A plus B plus C. That what we had to find it out. What is the result of adding the two equals opposite vectors, and you have to consider the vector A, and then since the magnitude of the vector that are same but the directions are opposite, and the resultant vector has a zero magnitude and represented by 0, so that is called a null vector or a zero vector. So in that same way, null vector or zero vector, which is equals to A minus A equals to 0. Magnitude of 0 is equals to 0 here. Since the magnitude of the null vector is 0 and its direction cannot be specified here, and on the same way here we'll be going for a detail that the null vector also results when we multiply a vector A by a number 0, and then the properties of 0 are, it will be A plus 0 equals to A, lambda 0 equals to 0, and 0A equals to 0. On the same way, what is the physical meaning of the zero vector? That is, consider the positions and the displacement vector in the plane. And now suppose that an object which is at P at the time t, that moves to the P dash and then come back to P, and then what it is the displacement, since the initial and the final positions coincide and the displacement is a null vector. Now we talk about the subtraction of vector, which we'll discuss in the next coming class. So here we're gonna end up with this only. And first of all, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Other than this, we had done your reasoning, which is verbal reasoning and the non-verbal reasoning. And the same way we are dealing with the quantitative. We started with quantitative aptitude. In that we had done or started with arithmetical ability. We had started with the chemistry as well. We had completed your part 1 chemistry for class 11, and part 2 we are dealing here. In terms of physics, part 1 for class 11, that is we had done your physical world. Unit 2 is your units and measurement, we had done. Unit 3 is your motion in a straight line, we had done. Unit 4 we are dealing here. After completing that, we'll deal with laws of motions, we deal with work, energy and power, system and particles of rotational motion, and then we'll complete the gravitation. So here we're gonna end up with. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you. Please like, share and subscribe, so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Thank you.